Okay, Cody, this is lesson 6-3. Okay, so proving or verifying an identity means to show both sides of the equation are the same. To prove an identity, simply simplify one side until it looks like the other. And here's your hint. You start with the more complicated side. It's easier to simplify something that's complicated than to make something not complicated complicated. Look at over here. So you look at the first side of the equation and see this is definitely the complicated side, right? And this is the not complicated side. I could not make the uncomplicated complicated. That would be very hard. I wouldn't even how could I make that? This is a true statement. So here's what you do. You do not bring, this is a question mark. You know the answer. You have the answer. The answer for me is the work that gets you to the other side. So can you manipulate this side right here and get it to look like the other side? Okay. All right. So the first thing, I'm just looking, what could possibly happen here? What could we cancel, reduce?
It's 1 over sine.
Okay. Okay, can't bring anything over to the other side. That's the only thing you can't do, is you can't bring anything over to the other side. You have to work one side and get it to look like the other. Okay, so it would be great if like something canceled right here, but I don't see anything that cancels. There's no distributing. So I guess we'll change this to 1 over sine. Okay, and you can rewrite this side, or you can write like apostrophes to say you're just bringing that down. You want to get that side to match. So let's go ahead and multiply these. Okay, what do you think? There's literally only one thing that we can do at this point.
Cross out the sign.
Okay, can't cancel the sign. Killing a cat. There's a plus sign between it. Can't and you're multiplying. Okay, common denominator. So I need, this one's okay, but I need this one to have a sine of theta. But hey, it's going to work things out for me anyway. Okay, what's sine of theta times sine of theta? Sine squared. So I'm going to have cosine squared of theta plus sine squared of theta over sine squared of theta. Okay, and I know what my answer is. What am I working towards? Cosecant. I should get cosecant as my answer. I know what I'm working towards. I just have to do all the mess. So, what is, you cannot cancel out. Okay, this is an identity. What is this right here? 1. That's 1. Look for identities. That's the whole point of this lesson, is looking for identities. So, that's an identity. I'm there, right? 1 over sine is cosecant. Now, go ahead and follow through. I'm grading your work. We know the answer. I don't care about the answer. I want your work. Your work is showing, yes, cosecant is equal to cosecant. And I proved it. So, it's exactly what you did before, okay, yesterday and the day before. But you know what your answer is, which is nice. Okay, so you know what you're going to get, but you've got to show how you get it. You have to prove it, that it works. Okay, and I'm grading the work that gets us there. Okay, so let's look at the next one. This should help some of you even finish up. So on this one right here, decide which side to work off of. Which side do you think is more complicated? Okay, the left, it looks more complicated. The right...
No, but the left you can cancel out stuff, so the right's more complicated.
And the right is less complicated. I can't like put anything together. Like they just say subtract. So as of right now, I don't know if I could put them together. But this one, I could maybe sub something in. I don't know. So which side do y'all think is more complicated? I don't know. I think they're equally the same. I think I can work off either side. But I know what I'm working towards. So, personally, I think the paper works off this side, but I feel like I could work off the other side just as easy. But there's an identity for sine. What's the identity for sine? You could do sine squared is 1 minus cosine. So 1 minus cosine squared of y over cosine of y. And then could I break these apart? Possibly? Do y'all know what I mean when I break them apart? Like I could split them apart under one denominator?
Couldn't you cancel out the cosines?
Okay, well, I can do it now. I couldn't do it then. Could I do it when there was a minus sign between them? No, but can I now? Yes. Okay, what is cosecant over y? It's secant, all right? So I can go ahead and put that in. And then y'all said canceling. This cancels with one of those. And so I'm there. Right? I proved it. I split them apart right here. And I put that as a single identity. And then that root simplified. And now I have what that was over there. Now, I really think I could have done it the other way and got the same thing. Okay? Feel free to do that, honestly. I think it would be just as easy to do the other way because you could have I'll do it in red a little bit, but this would be 1 over cosine. Okay, y'all watch me for a second. 1 over cosine, and then this right here would be cosine over 1. And then could you not get a common denominator? Okay, they don't cancel. So the common denominator would be cosine over y over cosine of y.
Hey, ask Miss Quigley a question about your homework.
Okay, let's look at the next one. All right, Jane, left or right? Which side would be the side we ought to work on? Okay, we want to work off the right. Are y'all looking at it? We're going to work off the right. I see something that will factor out.
The sine.
The sine squared will factor out. So I can have sine squared of alpha, cosine squared of alpha minus 1. You have to leave a 1 in that spot. Because if you redistribute that, you got to get back to where it was beforehand. So, okay, I see an identity. What's cosecant of alpha minus 1?
It's tangent.
It's cotangent. I've got it written on the board over there because I need it in front of me. So cotangent
It's cotangent.
of alpha squared. Okay, I know what I'm working towards, right? I know I'm going to cosine. What do you think I should do next? Brandon, have any thoughts? What do you think I should do next? Cotangent's what? What is cotangent? Cotangent is cosine over sine. Look what happens.
Whoa.
Maggie's favorite thing to do right here. What can you do now, Maggie? Because there's a time sign. You can cancel, and we're there. Hallelujah. We'll have a chorus, a hallelujah chorus after we prove an identity.
Can we do that every time?
Hallelujah. Hallelujah. I'll get y'all started. I'm not quite a very good singer. I was all alone on that. Okay, this one right here.
Man, Cody, I miss you.
This one right here, what do you think we should do? Which is the more complex, Shelby? Which side should I work off of?
The left. Yeah, left.
The left. Now let me show you this. We like canceling. If you distribute this tangent, would it not cancel with that on the bottom? Yes? Well, I can. And then, but I got to distribute it there too. So I'm left with secant of x over 1, because that canceled, minus tangent squared of x over secant of x. Okay, so now I know I'm going towards cosine. Now what? What's the only thing I can do now? And don't say cancel. Common denominator. I can't cancel because of the minus sign. You cannot cancel. You need a common denominator, which is secant of x. Secant of x. Okay, so you're going to be left with secant squared of x minus tangent squared of x over secant of x. McKenna, what is that in the numerator? It's an identity. And there it is. It says secant squared. It says minus tangent squared. That is what? It's actually a positive one. It's tangent minus secant that's negative, but this one's secant minus tangent, so it's positive 1. So, and plus we know where we're going anyway. What's 1 over secant? I just put a minus. It's cosine, and I'm there. So cosine of x is equal to cosine